So 4.3, we're looking at writing functions. Then we're going to be doing this function notation down here, which a lot of books, they refer to it as Euler's notation, or sometimes people pronounce it Euler's notation. But okay, so we're going to do this independent, dependent variable. So the dependent thing here, so dependent depends on the independent. So the dependent variable always depends on the independent variable. So what I would recommend doing is if they give you two variables like bill and temperature, ask yourself, well, does the first one depend on the second, or does the second one depend on the first? And what I mean by that is, and sometimes they'll both make sense, but you're looking at which one makes sense without you having to make like a conscious choice. Which one just kind of naturally happens. So your winter gas bill and the outside temperature. Does the bill depend on the temperature?
Yes.
Or does the temperature depend on the bill? The bill depends on the temperature. Yep. So this one here is going to be the dependent. Or that's going to be where you put the y variable or on the y-axis. And this is going to be the independent. It's not like if you pay more, then the temperature will be higher. You know, the temperature doesn't depend on the bill. The length, the shower length, so how long you're in the shower, and your water bill. So does the time in the shower depend on the bill, or does the bill depend on the time in the shower?
Yeah. Bill depends on the shower.
Yep. So that is kind of naturally, the bill just depends. And then this here's going to be the independent. You could try to argue the other way, that, well, if water's really expensive, you know, then you're going to take shorter showers. So the length of your shower does kind of depend on your bill. But that's like you choosing to take a shorter shower, where the other way just naturally happens. The bill just naturally depends on how much water you're using. All right, last one. The knitting time, the time you spend knitting, does it depend on the length of the scarf?
Yeah.
Or does the scarf length depend on the amount of time you knit?
Scarf length depends on time you knit.
Yep. That second way makes a little bit more sense. The length naturally just depends on the time that you knit. You could argue the other way around, but the other way requires thinking like, oh, I want a long scarf, so then my time depends on the length. But that's like you choosing to knit more time to get a longer one, where the length just naturally depends on how long you've been there knitting and purling and stuff. So we okay for those? Cool. So function notation, often called Euler's notation or Euler's notation. It's actually it's named after a French mathematician from the 1700s, Leonhard Euler. But this here, okay, so I just put this line in because you get a question or two where that kind of pops up, and they say, is this a function of this? So they always say the dependent variable is a function of the independent. So if they give you two different variables and they say, you know, the length of a scarf is a function of the time you spend knitting, you know, then because they said the length of the scarf is a function of, then the length of the scarf is the dependent. Fair enough? If I lost you a little bit, you'll figure it out when you get there, I think. So the equations are usually going to be in the form of y equals something with x. So usually when we get equations, it's like y equals 3x plus 9, y equals 7x, y equals x plus 2, something like that. So this function notation is really just a fancy way of writing y equals, or a fancy way of writing y. What they do is most often, the most common one is they do something like this. They'll do f of x. And that f of x is really just a fancy way to replace y. It's another way to write y, but that's called function notation. So that's function notation. And so it's written, or it's said like f of x equals, so it's not f parenthesis x parenthesis equals. It's just they say f of x. It's possible to use other letters that sometimes you'll maybe see like a g of x, or maybe they'll do like a t of x. And sometimes that letter in front will stand for something. So g of x is the number of giraffes after x years. So they use g, or t maybe is the amount of time for something. But they could pick any letter for in front of the parentheses. The letter that's in the parentheses is always going to be the same as the independent variable over on the other side. So I wouldn't stress about that a whole lot, but let's just kind of go. So the key is this. I'd like triple starred it over here. And I'm going to say, before we even do the problem, replace the variable. And by that, we're pretty much talking about the x, replace the x. So replace the variable with what's in the parentheses. So replace the variable with what's in the parentheses. That if you remember this one thing, you can bluff your way through almost all the questions on the quiz or the test if you do that. So if you're ever stuck, just come back to, okay, whatever's in the parentheses, you just put that in for the variable. And what I mean by this, we get a question that says f of x equals 3x. So really this is just an equation. It's kind of like saying y equals 3x. Fair enough? And they say find f of x, find this kind of new y value thing, when x equals 8. Would you agree if x equals 8, you could put an 8 right in there for x, because x is 8. So if I were to take my problem and do f of 8, do you see how 8 is in the same spot as the x? So hopefully it kind of helps make sense then that x would just, or 8 would just replace the x. So it really is just 3 times 8. Because 8 is in the x spot, so x is just 8. And 3 times 8 is 24. So the book starts out giving you problems written like this, and then later on they're just going to say, find f of 8 this way. So they don't say find f of x when x equals 8. They just say find f of 8, and it automatically starts with your 8 right there in the parentheses. So, all right, if we go with the same equation, f of x equals 3x, f of 12 is going to equal what? 36. So the answer then is going to be a 36. To show your work, well, if you take and copy that equation, our original equation, this thing here, and I just put the box around, equals 3 times x. Well, if we do this, then we know that x is just the 12, so we could put a 12 in there for x. So we get 3 times 12, which equals the 36 that some people came up with. Good? I kind of hacked it all apart there, but you kind of getting an idea? If we flip the page, so just try to give you like some new equations to work with. So if we start out now with f of x equals 2x minus 4, we're trying to find this f of 7. So we're trying to find f of 7, or what's y when x is 7. Do you agree we just take 2x minus 4 and put in a, yeah, nice, a 7 for the x? So we get 2 times 7 minus 4. 14 minus 4 is 10. So you could say f of 7 equals 10, or the answer is just going to be 10. The next one, now we're using g of x. Same exact thing. Don't let the g throw you. We're trying to find g of 17. If you line it up that way, maybe that'd help it make sense. But really, we just replace x with 17. So 17 minus 4. 13. So the math itself isn't hard. I think what maybe makes this challenging for some people is it just looks weird. It's just different. But if you can just get past how it's different, then you'll be fine. If we go down to now write an equation, you'll notice this last question we have here, that instead of putting a y value in here, they replace y with the f of x. But normal questions like this, we would just go through and say, all right, how do you get from 1 to 8? Well, we could add 7. Or we could multiply by 8. All right, this next one we could add 9. Ooh, so it's not the addition, right? And it's, or multiply by 5.5. Well, that doesn't work. Okay, so it's not one of the easy ones, right? So if neither of those work, does anybody remember what we do next? Go for it.
Don't you do like how many numbers are in between like 8 and 11 and then
Perfect.
14?
So this is going up by 3. This is going up by 3. So every time x goes up by 1, from 1 to 2 and from 2 to 3, the y value, or the f of x value, goes up by 3. So let's just pretend this is a y for now, just to not make our brains hurt any. So what does that tell us about our equation? Our equation must have a y equals, how does that 3 factor in our equation?
X.
Perfect, the 3x. because every time x gets 1 bigger, we want y to be 3 bigger. So it has to have a 3 times x. You guys okay with that? So, because now every time we get 1 higher for x, y is going to be 3 bigger. Because we multiplied by 3 one more time, it makes it 3 bigger. But if we take that now and put a 1 in, so we have this here, 3 times 1 doesn't give me 8, right? It gives me 3. So what do we have to do to that to make it turn into an 8? We add 5. And now we hope like crazy that works for all of them. So if we look at, well, 3 times 2 gives me 6, plus 5, 11. 3 times, put the 3 in for x. 3 times 3 is 9, plus 5, yes. And 3 times 7, 21, plus 5, 26. If you notice a couple comments, switch to the retina burner green. If we go here, this is plus 12. So it seems like it breaks our pattern, right? So our pattern was y goes up by 3 every time x goes up 1. Up 12 is up 3 how many times? Does that make any sense? Yeah, 4 times. If you add 3 4 times, you get adding 12. Well, do you agree we really have 4 steps up here? Because x is 4 bigger. So it's kind of like it gets 3 bigger 4 times. So it does fit the pattern there. Final thing, and I don't know if I can actually, I can't erase this, but we replaced right here, we replaced f of x with y. So if they say write it in function notation, the only change we make is we change y to, f of x. So instead of y equals, it's f of x equals 3x plus 5. So that'd be the final answer.